Assalamualaikum and very good morning, ladies and gentlemen. You are in oil and gas basic E&P training. Let me recall. In the last session, we were talking about seismic survey as geophysical exploration method. As you can see in the picture, seismic vessel is used for carrying out seismic survey. Seismic survey vessel tows an array of sensors such as geophones or hydrophones in the water to map and record the geophysical attributes to the subsurface. For onshore seismic survey, trucks are used for seismic acquisition rather than ships. However, all steps in the process are the same. Sometimes the survey area are in swampy conditions, hence flat bottom boats are used. The pictures here show how field geologists working with constraints in order to acquire seismic data at complicated seismic geological conditions. Sometimes they have to travel together by helicopter or boat to conduct the survey. In exploration, geodetic methods allow only the surface monitoring. However, the processes causing the movement of masses can occur at depth without noticeable surface changes. Therefore, geophysical methods such as georadar sounding and seismic exploration can be used to locate what is present underneath the Earth's surface. Seismic surveys are conducted by deploying an array of energy sources, an array of sensors or receivers in the area of interest. Travel time in seismology means time for seismic waves to travel from source to receiver and use those data to estimate the properties of the subsurface. Amplitude is often found to correlate strongly with porosity and liquid saturation, because these reservoir properties have a strong effect on both velocity and density. And seismic reflections are generated at boundaries where acoustic impedance changes. A bright spot is a local high amplitude seismic attribute anomaly that can indicate the presence of hydrocarbon, and it is therefore known as direct hydrocarbon indicator. Particle motion consists of alternating transverse motions. The signal recorded at the surface can be used to explain the properties of solids, liquids, and gases. Velocity analysis is a step in the seismic data processing with the objective to determine the seismic velocity of a given medium, for example, a medium arranged in layers. Seismic waves travel through different materials at different speeds, and we can apply knowledge of how they interact with different materials to understand Earth layer and internal structures. There are three phases of seismic surveys: data acquisition, processing, and interpretation. Seismic acquisition is generally accomplished using large ships with one or two multiple air gun arrays for source. Seismic waves are sent deep into the earth and allow it to bounce back. Geophysicists record the waves using sensors which are called geophones. An energy source air gun is used to send seismic wave down into the earth. The air gun arrays release compressed energy, generate a powerful pressure wave. The pressure wave travels, then propagates on downward to illuminate geology. The reflected wave fields then come back up and travel to hydrophone cables. The hydrophones record this reflected wave field and digitize the upcoming seismic reflection events. A seismic program is expensive and time-consuming. Collecting and processing the data can take 12 to 18 months. Sophisticated computer imaging of subsurface and structures can enhance the likelihood of successful wildcat well. Seismic is used after a play has shown some promise by the basin analysis and aerial surveys. There are three basic types of seismic technologies used to help explore for oil and gas: 2D, 3D, and 4D. Two-dimensional 2D seismic data are collected from each ship that tows a single hydrophone steamer. The result displayed as a single vertical plane or in cross-section that appears to slice into the subsurface beneath the seismic line. Three-dimensional 3D seismic data collection employs one or two more towed hydrophone steamers. The arrays are oriented so that they are towed in a linear fashion, such as in a rig pattern, where several lines are towed in parallel to cover area of interest. The results display as a three-dimensional cube in the computer environment. And 4D seismic, also called time-lapse seismic, requires an initial and baseline seismic survey of a subsurface area with a subsequent monitor survey of the same area copying as precisely as possible the initial acquisition survey, parameters, and conditions. This method allows comparison of seismic over interval of months or years to detect changes resulting from the production of hydrocarbons. Sophisticated computing systems are used in processing and interpretation. Seismic interpretation is the science of inferring the geology at some depth from the processed seismic record. The interpretation process can be subdivided into three interrelated categories: structural, stratigraphic, and lithologic. The data recorded from a seismic survey is originally in its raw or unprocessed form. Before it can be used, it must go through a series of computerized processes. These processes, filtering, stacking, migrating, and other computer analysis, make the data usable and require powerful computers and sophisticated computer programs. The resulting processed data must be interpreted by the geophysicists and or geologists. All seismic data is subject to interpretation, and no two experts will interpret data identically. Seismic data are a result of sound waves collected and processed to see the subsurface. Seismic interpretation aids in constructing the most accurate Earth model or reservoir description possible. Properly processed and interpreted seismic lines can show good ties or correlation at intersection points. Properly tying all available data, including seismic data, well log, check shot surveys, eliminate ambiguity in interpretation. Whenever we have well data and seismic data, we need to relate the two. Example, how does the top of sand in the well relate to seismic? We want to be able to relate features from well data, tops, faults, chord intervals, to the peaks and troughs on the seismic line that pass through the well location. The picture shows typical seismic across whole sedimentary basins. Typical seismic cross-hole sedimentary basin, approximately 150 kilometer, records down to 8 to 15 kilometer deep. The record length should be long enough to ensure the latest expected arrivals are recorded. Sedimentary basins are formed over hundreds of millions of years by the combined action of deposition of eroded material and precipitation of chemicals and organic debris within water environment. Over time, continuing sedimentation occurs in the water environment and the additional weight causes subsidence. Organic matter and different material deposited at different times over thousands of years will produce regular layering of strata in the basin. Volcanic action of the movement of earth crust causes faults to appear in the basin. By having a 3D seismic cube, we are able to develop a precise and reliable structural model, define more accurately water and oil contacts, define more accurately the size of the field, design more accurately well trajectories, properly place injector producer wells, design more accurately the injection patterns, estimate reservoir quality, seismic intervention data, compute gas reserve attributes AVO analysis, incorporate undeveloped areas, and also to discover a new prospect. Three-dimensional seismic is an advanced method for collecting, processing, and interpreting seismic data in 3 dimensions. 3D seismic data is collected from closely spaced lines over an area of interest. The advantage of using 3D seismic include increased resolution and improved interpretational tools and data displays. Seismic data processing and modeling. The comparison, simulation, or representation of seismic data to define the limits of seismic resolution, assess the ambiguity of interpretation, or make prediction. It will represent a physical property of entity that can be used to make predictions or compare observations with assumptions. Contribute towards improving estimation of reserve and making decisions regarding the development of the field. Seismic data is an important source of information to guide the constrained reservoir modeling. Seismic interpretation are used to constrain the structure of reservoir models. Different seismic attributes can support the identification and definition of stratigraphic features, and seismic inversion products can help constrain the rock properties. Combining seismic data and well log data makes it possible to estimate the reservoir properties in field scale. Now, part of important exploration is a reservoir property, which is porosity. The measurement of porosity is important in oil and gas exploration and oil and gas development as a whole because the porosity determines the storage capacity of the reservoir for oil and gas. The property that tells how porous a rock is. It defines as a measure of the capacity of reservoir rocks to contain or store fluids. The ratio of the volume of void space to the total volume. It determines the rate at which the fluid can be produced. The accuracy of rock porosity is crucial for the oil and gas industry as it affects the calculation of hydrocarbon volumes and recoveries. Error in estimating porosity can lead to significant errors in reserve estimation. Almost all hydrocarbon reservoirs are composed of sedimentary rocks in which porosity values generally vary from 10 to 40% in sandstones and from 5% to 25% in carbonates. Effective porosity should be high to be a good producing reservoir. Good porosity reservoir having pores which are interconnected and contribute to the fluid flow. Density increases and porosity decreases monotonically with depth. The storability of rock is directly proportional to effective porosity. Higher porosity leads to greater storage of petroleum. Another important fact about porosity is that if the source rock is of desirable porosity, then it will be easier to extract and inherently produce high volume, as highly porous rocks can contain higher volumes of oil, therefore being less expensive and more profitable than source rock with low porosity. Because a source rock with low porosity will make extraction much more difficult and produce lower volumes. Another important property of reservoir is permeability. Permeability will define how easily hydrocarbon will be able to flow. It measures of the ease with which fluids can pass through, the capacity of rock layer to transmit water or other fluids such as water. Permeability is one important property to determine the effective reservoir. Reservoir rock permeability is a key milestone because it is important for being used to determine if it is really sufficient accumulation of oil. A rock that is both porous and permeable would make a good reservoir rock, as it allows oil and gas to move up through the pores in the rock closer to the surface where it can be extracted. The greater the permeability, the easier it is to extract the oil from the rock. The last part of exploration I want to share with you is stratigraphic column. Stratigraphic column is a visual representation of field crop, field measurements of bed and unique thickness. The purpose of stratigraphic column is to give visual representation of the field, including the unit names, ages, thickness, and descriptions. It shows weathering conditions and weathering profile, which are the long-lasting roots of surface soils, and their properties reflect the cumulative effects of weathering under changing climatic, biotic, and geomorphic conditions. It also indicates lithology of the geological units exposed in the area. A typical stratigraphic column shows a sequence of sedimentary rocks with the oldest rocks on the bottom and the youngest on top. In weathering profile, you can see formation of siltstone, shale, sandstone, conglomerate, and limestone. As you can see at the bottom of the column is formation of conglomerate and siltstone deposited in river and floodplain environment. At the top of the column is limestone formation deposited in marine environment. These are sandstone formation in the columns. There are sandstone formations in the columns deposited in desert dune environment where the relatively high porosity and permeability sandstones make them good reservoir rocks. This will end exploration session of our training. I hope you have good understanding of oil and gas exploration. Our next subject is appraisal cycle in the life cycle of oil and gas field. Until we meet again, have a nice day. Everyone, thank you.